Remember, while you're doing this, so you should be trying to do this by hand. Yes, you could check it in Desmos, but we shouldn't be relying on Desmos. We should be trying it on our own and then checking Desmos afterwards. So right now, go ahead and close laptops because we no longer need them. We can figure that out later. Go ahead and close it. Alright, with this problem, there were different ways you could have started this, but one of the easiest, short ways you could have started this was to distribute the -3 right here to both of these. You can use your calculator to do that if you can't do that in your head or don't want to do them as math. I did a lot of that already. So make sure you're hitting the -3 and then times your fraction going to alpha y equals to get the 5. Oh, sorry, I skipped a step. Okay, to get the 5, 6. So alpha y equals to get your fraction. You are going to live there a lot of the time, so you'll need that. And then just scroll down to get that last part, which should have given you -5/2. Don't forget your x, because that can change your entire problem. -3 times -2 would become a +6. And then we can keep going. We can combine our like terms, this 5 and this 6 on the same side. Remember, you can only combine like terms if it's on the same side, otherwise you're adding or subtracting. And then you have choices. So after you get to this, if what you did next is not exactly what I do next is not exactly what you did, it's okay, because there were different options. So I like positive numbers. I'm going to move this over by adding it. And at the same time, I'm going to get rid of the 7 by adding it also. I could just add these. 5 plus 1, 6 over 2 is 3, or I can also use my calculator for that. Go into your fraction bar and add 5 over 2. Come out of it before you hit plus, and then do it again to get 3. We got 3x and then 18, and if we divided both sides by 3, we would get 6. Did we have any questions on that one? That one was kind of challenging because it was fractions. There were a lot of like terms, fractions on both sides. But if you got that, great. If not, we're going to keep practicing it, so no worries. Okay. For the number 3, he already solved this. Andre already solved this. So we just need to answer this question. What does Andre's work show us about the type of solution to the equation? So this is the solution he got. What type of solution is that? No solution. For a couple different reasons. 1, 2 equals 0 is not a true statement. It's not a true equation. But also, the variables disappear. So when those two things happen, you get no solution. You can accidentally make your variables disappear. But that wouldn't mean it's no solution. But if you did it correctly and 3 minus 3 is 0, and they disappear, and you get this, then it is no solution. Okay. Questions on that? I mentioned last class that you did have a Delta Math test due tomorrow on what we did last class. Some of you started that already, and I appreciate you. Make sure you do continue working on that you do that. Did anyone have questions about that? Like maybe they were working through it and they got stuck and they're not sure what to do next. We can go through problems. Maybe just one for right now. You had one. Okay. Did you have one that you got stuck on?
Yes.
Okay. I can pull it up.
Oh, except I moved my thing. Kennedy, come here, please. Like one of these.
Yes.
Yes, okay. So we'll do this one.
Okay, thank you.
So we're going to do this problem. Alright, this may not be a problem you get, but it may be similar. Please. Remember that anytime you get a fraction that equals another fraction, what should be your first step? Cross multiply, good. So I'm going to take everything in this numerator and multiply it to this 5. And then take everything in this denominator and multiply it to this 3. And I'm going to rewrite it first. Does not matter which part I write first. I just have to make sure it goes together. So the number I'm going to put outside of parentheses and put everything else inside. Sorry, I meant to say write this down either on the back of your paper or somewhere where you have space. And then from here, it's going to be very similar to the warm-up problem we just did. We're going to distribute on both sides. So we get 3x plus 18, and you guys can use your calculators also. You have Desmos to do like the math part if you need it at home, but also make sure you're trying the steps as well. 5x minus 40. And then we can move things. I'm going to move the 3x over just because it would keep it positive. If that's not what you want to do, it's okay. You have choices. And at the same time, again, you can do this in 2 separate steps. I'm going to move my 40 over by adding. So that this cancels, this cancels. 18 and 40 would give me 58. This would give me 2x. And then I would divide. And what would that final answer be? 29. Which I believe was the answer. Okay. Also, if you're struggling with any of the Delta Math and you don't get to a question, you don't get it answered in class, please come see me after school today or tomorrow. Ms. Shepherd after school tomorrow so that way we can help you. Do you have any questions about this? 11:59 tomorrow. So you have time. Yes, yes. Now be here till 3:30 today and tomorrow. So we talked about multi-step equations and how to solve those. Now we're going to talk about literal equations, which is going to be it's going to be different. I'm not even going to say slightly. But first, let's get into this. What is the difference between the following two sentences? It's raining cats and dogs. It's literally raining cats and dogs. What's the difference? So this one is like there are actual cats and dogs falling from the sky, and this one is raining so hard it feels like there are cats and dogs raining from the sky. Yeah, literally is the hyperbole if we're tying in some English there. Some other literal examples, like when you say I got your back, you're not talking about this because that would be extreme. So when we talk about the word literal, it means actually or without exaggeration. But when we talk about a literal equation, so in general, it involves several variables. We're going to pick one. Nope. It's going to pick one. There will be one that is picked. And we are going to actually solve it using the same operations that we solve using for regular problems. And then we just actually solve it for whatever the variable is. But we don't get a numerical answer. That's where it's different. So because we solve equations all the time, we want to get an answer, but we're not going to get an answer, and we just got to be okay with that. So like this example, if I were solving this for x, and I got y, I got rid of y, I could put in all these different variations. I don't know what x and y represent, but if I knew those numbers, I could rewrite it and get exactly what x or y equals. So go on to the next page. So this is a lot of helpful hints. If you get stuck, go back to this. There are a lot of variables. Some of these problems have a lot of variables. So you may want to circle or highlight or underline whatever variable we're solving for. Be thinking about your order of operations. Be thinking about how to remove fractions and things like that. How would we get the variable by itself in general? And if we need to, you can do the last one. So we're going to do some regular equations, and then we're going to solve a literal equation and kind of compare and show you how that is done. Right? So for example 1, how would we get rid of the 2? How would we get x by itself? Divide, yes. So that x equals 5. And that would just be our answer for that numerical, bless you, for that equation. Now in example 2, we have a very similar setup, but all we see is variables. We're going to solve this for h. We want to get h by itself. How could we do that based on what we just did? Did you remember what you said? Okay. Think about what did we do here? What could we do here? Divide by g, yes. We're going to divide this by g on both sides, just like we did here. However, the g's cancel here, just like the 2's cancel here. That part still tracks. But m and g are two different variables. I cannot do anything with them except to rewrite it. So this would be h equals m over g. Yes. So we have some random equation that I don't know anything really about. If I had some numbers to put in, then I could figure out the actual numerical format of h, but I don't. It's just to figure out how could I find h by itself. What questions do we have so far? We're going to try this next one. Example 3. Another equation. We're solving for x. How do we get x by itself? Subtract 5. Thank you. And now this looks just like our previous problem, so we would divide. We get 3. Now, example 4 is very similar setup to example 3. We are also solving for x in this one. What would we do first? Yes, subtract b on both sides. And the b's are going to cancel, but I can't do anything with this. I'm just going to rewrite it. ax equals c minus b. What would the last step be? Divide everything by a, yes. So that these a's cancel, and I'm left with x equals c minus b all over a. Again, I have no idea what that means. If I had some numbers, I could put it in there and figure that out. But I can't. I don't. Questions so far?
So you just leave it out when it's at.
Mm-hmm. So once you get that by itself, that is the answer. Yep. So it doesn't seem that hard. There are just a lot of letters and you have to process it, work through it slowly if you need to. Okay. So now in example 5, we have numbers and letters mixed together. If we were solving to get x by itself, what would we do first? What were you saying? It might have been right.
Divide.
Mm-hmm. Not divide yet. Add. We are going to add something. So I wouldn't touch anything related to the x or close to it. We're going to do that later. But this term right here has nothing to do with x at all. We can get rid of it by adding it to the other side. I told you were on the right path. I just didn't hear everything you said. So add 6y to the other side. And remember, these are not like terms. They both don't have y's, so I cannot add these together. I'm just going to rewrite it. Now, when I go to get rid of the 3, if this were some number that 3 does not go into, like 8, I could just divide this entire side by 3 be done. But because 3 goes into 6, I need to divide this separately to each thing. That way the 6 and the 3 can simplify. This is just going to stay a fraction. Let me do that. Whoa. But this can be simplified, and then that would be your final answer. X equals 17 thirds, or 17 over 3, plus 2y. What do you say? Do you have any questions on that? We're going to do another, then you guys are going to have some time to practice and just for a couple minutes, and then we'll come back and do some more. 7 and 8 are very similar. Which one do we want to do, 7 or 8? 8. Okay. So the setup that is similar, but now we only have variables. So if we're trying to get A by itself, what would we do first?
We would divide B.
So we will divide B, but not first. Just say it. It's okay. Subtract what?
A, B.
C. This whole term.
Oh, okay. We could do that?
Yes. So we can subtract that whole term. It has nothing to do with this term. So we want to get rid of it so we don't have to worry about it. Move it to the other side. G and CD can't be combined, so I'm just rewriting. And then our last step, divide by B, yes, to both sides. And this one you can do to the entire side because there are no other B's. So A equals G minus CD all over B. Any questions?
So does the G, with the G ends up of the top one, the numerator?
Because we divided this entire thing by B.
Oh, okay.
Other questions? This is not something you can really check in Desmos. You just have to make sure you're double checking your math.
How do we check?
So what you could do is pick different numbers
Yeah.
for each variable. I wouldn't use 0, I wouldn't use 1, 2 is iffy sometimes, so pick like 4 different numbers, put them in like this, and see if you get this one. Like see if this is a true statement, see if this is a true statement. Alright, I want you guys to try 7. I'll give you a couple minutes to do that. If you finish that before we come back together, try number 6 also. But really just try 7 for right now. Alright, let's come back together. Do we want to say the answer or work this out together?
I should have
Do we want to work this out together up on the board, or does someone have the answer and want to say what they think that is? Did anyone get an answer? Let's start with that. What did you get?
I got C equals CD.
You got G minus CD.
Yeah. Over B.
Okay, you're close. But if we were solving for C, we wouldn't still have C in here. It should be E. And then this should be E, yes. Alright, so let's just work that out. That way we all have it. So if we were solving for C, it's similar to this one, but opposite. We would have gotten rid of the AB. And then divided everything by D. Okay, guys, it's okay. Alright, it's alright. Alright, so we're gonna go on to the next page. Do whatever practice problems you guys feel like you're not sure where to start, and then you'll have time to practice on your own in just math and whatnot. Right? So once you're done writing, look on the next page. Find any questions we want to see, do go over, have questions about it.
Yes.
We don't have them. Working on that. Right. Are there any questions on this next page that we want to see you go through? Have questions about how do we start this? I'm confused.
Number 6.
Number 6.
Any others? Five. Yeah.
Is it just this page or?
The next page is very similar, but if you have one on there, you can do that too.
Number 7 on page 4.
Okay.
And number 5 on page 4.
Alright, I think that's a good amount. So, starting with, and in 5th period we did some different examples, so later when you're at home, if you want to go back and rewatch that video, you can go find theirs too. But you don't have time to do all of this. Alright, in number 5 on the first page, we want to get B by itself. We got to get rid of C and D. What do we think we would do first? We're already dividing.
I like that you read the straightforward math. Come on now.
Subtract.
What's the opposite of dividing? Yeah, so we're still going to do something with the D, get rid of it, multiply on both sides. Because when we multiply this entire side by D, D's cancel. And we don't have to worry about it. It does not matter if you put A, D, or D, A, same thing. I just put it in ABC order. Okay. And then to get rid of C, we would do what? Subtract. We'd have AD minus C, I did not do that, equals B. Questions on that one? Did you have a question? That way we don't gotta worry about it later. 6 is a little bit more challenging because we have a little bit more steps. So we want to get B1 or B sub 1 by itself. But right now it's inside parentheses. So we got to get rid of those parentheses by getting rid of whatever's outside. So first we're going to get rid of this 1/2 by taking it and flipping it and multiplying it on both sides. Multiplying by the reciprocal. Remember that's what that's called. That way the fraction that goes away, we don't have to worry about it because they cancel. This is 2/1, but that would just simplify to 2. So this would just be 2A. And then we can do one of two things here. Either distribute the H or divide it. Which would we rather? Distribute, okay. So when we distribute the H, just like we would distribute a number, we're going to multiply it to both things inside. So that we get 2A equals HB1 plus HB2. But we still got to get B1 by itself. So we can get rid of this entire HB2 term by doing what? Subtracting it. After I write this. I'm going to move up just because I'm running out of space. So we have 2a minus hb2 equals hb1. Now we got to get rid of that final h. What would we do there? Divide, yes. And because we distributed out that h, there's now another h that can be simplified. So now we have to divide each thing by h. Whereas if we had divided by h at the beginning, we wouldn't be doing this now. So it kind of depends, however you start to solve it. So that we get these h's cancel, these h's cancel. 2a over h minus b2 equals b1. Yes. Oh, those are half of them. Got it. It does kind of connect in a little bit. Questions on that? On to the back so we can do 5 and 7. So starting with 5, we're solving for z. So we want to get rid of the 9 and the 2a. What would be our first step? What could we do first? Say again. Divide by. So if you wanted to divide, it would have to be the number which is closest to z, and then you'd end up with fractions first and have to deal with that and move that. So you might still end up with fractions regardless, but you may want to wait until the end to do that. Huh? Yeah. So I'm going to just subtract this to the side, and then I'm going to put this in ABC order. So 9z equals negative 2a plus 3j minus 4x. Because none of those are like terms. I can't do anything with them. Just reorder them. Now, if this 3 were any other number that 9 can't be simplified by, we would just divide the whole side by 9. But because the 3 is there, we have to divide each one separately. 2 of them are going to just, actually all 3 of them are going to be fractions. So this would just be negative 2a over 9. Plus, this would reduce to 1/3. So you can write that as 1/3 of root 3j, or you can write it as j over 3. Those are the same things. And then minus 4/9. So there were really only 2 steps there. It just looks like a lot because of all the fractions. Do you have any questions on that?
How do we get 4 just doing it?
So these are the same things. These are the same thing because there's an invisible one. And I could rewrite it. Yeah, just that middle one is the same. Alright. I don't have space to write this beneath, but you should. I'm just going to write this on another page. Pi and squared. If you need me to go back. Alright, for this one, we need to get r by itself. This is pi, the pi symbol. It is some number, but we're just going to treat it as if it were a variable. We're not going to actually write out 3.14 or any of that. So the very first thing, divide both sides by pi. Get rid of that, that way we don't have to worry about it. This is how I draw my pi symbols. I don't know how to do the fancy little whatever, how it actually looks. Now, we kind of touched on this when we talked about inverse operations. How would we undo something that's squared? It is that. It's the square root. So if I take the square root of this side, I have to do the same thing on this side, but the square root and the square cancel each other out, so that just r is left. Not agreeing.
Which one is this one? Which one is this one?
7. Oh, I don't know. Okay, and then I just want to mention one thing that you may or may not see on Delta Math for questions that look something like, I can completely make up one and it may not even be accurate. Just write this somewhere where you have space. If you see something like this, and maybe it's saying solve for m, well, this one has 2 m's, so that makes it a little challenging. What you want to think about when you get something like this is how we distribute, and then there's like we just did this for the h one. I'll come back to this, sorry. We distributed the h and there was an h for both. Right now there's an m for both, and I want to undo that. So I want to bring that m out front of parentheses so that I took it out and just left whatever is still there. And if I were to actually solve for m here, if this were just one variable, I would just divide it. I'm still going to divide it, but I'm just going to divide this entire thing. So that this entire thing cancels. So you may see something like that, but if you need help going through that, again, we can help you with that. Alright, I've been talking a lot, so I'm going to stop. You guys can do one of 3 things. Keep working in the practice in your notes. Continue working on your Delta Math. You have 2 Delta Maths that are due tomorrow. One that we talked about last class, the multi-step equations with variables on both sides, and the literal equations from what we were just doing. Those are both due tomorrow. They are both formative. The discussion on literal equation that is due today, that's informative, so do it if you have time, if you can, if you remember. If you finish one of those things, do something else of what I just said, one of the 3 things I just said. Questions on what we're doing for the rest of the class? Yes. Yes, you can use the iPads for Delta Math. Yes. When Adrian gets back to this. Alright, if you need